Welcome civil engineering viewers and students. Today we will try to find out the static indeterminacy of this rigid frame and also the kinematic indeterminacy of the same rigid frame. So first let me calculate the degree of static indeterminacy of this frame. Now here this frame has got a moment release, that is internal hinge at point E, as well as it is having an axial force release at point C. So first we have to apply the formula 3m plus or minus 3j minus c, where m equal to number of members and r is the number of reactions and j is the number of joints and c is the total number of members meeting at the hinge minus 1. Now number of members m is equal to, here the number of members is 1, 2, 3, 4, 5, 6, 7. So number of members is equal to 7 and number of reactions equal to, so this end is fixed, you will have 3 reactions. Now here you will have 2 reactions, so reactions is equal to 3 plus 2. Then at this location you have only one vertical reaction because it is a roller support, so here you add 1, so the number of reactions comes around 6. And now we will calculate number of joints j. So number of joints j comes around, here you can take number of joints here 1, 2, 3, 4, 5, 6, 7, 8. Number of joints is 8. Then we will calculate what is C1. C1 is equal to, if you take C1 here, at this location 2 members are meeting, so 2 minus 1. C2 equal to, here 2 members are meeting, C2 is equal to 2 minus 1, so equal to 1. Now the degree of static indeterminacy is, here the formula for static indeterminacy is equal to 3m plus or minus 3j minus c1 minus c2 equal to 3 multiplied by 7 plus number of reactions 6 minus 3 into j is 8 minus c1 is 1 minus c2 is 1. So if you calculate that, you will get 21 plus 6 minus 24 minus 2. So ultimately the answer is 27 minus 26, that is equal to 1. So this is the degree of static indeterminacy of this frame. Now we will calculate the kinematic indeterminacy. Okay, so how to calculate the kinematic indeterminacy? Here the formula is 3j minus r plus c. So we will have 3 into number of joints is 8 minus number of reactions is 6 plus C1 is 1, C2 is 1. So we have here 24 minus 6, that is the number of reactions, and you have here plus 2, so it is 26 minus 6, that is 20. So 20 is the degree of kinematic indeterminacy. So this is degree. So this is for extensible members. Okay, if you want for rigid members, you subtract 20 minus number of members, which is equal to 7. So that will give you 13. So 13 is for rigid members. You understand? So these type of questions are often asked in competitive exams. Okay. So I hope you have understood how to calculate the static indeterminacy, which is 1, and how to calculate the kinematic indeterminacy for extensible members. If the members are rigid, the kinematic indeterminacy is 30. The formula for kinematic indeterminacy is 3j minus r plus c. So this is how you are going to calculate the static indeterminacy and kinematic indeterminacy for these type of hybrid frames. Now we will move on to the next problem here. Now you can understand that this is the next problem. So we will solve it here. So in this problem you can see that this is a hybrid frame. So this frame is a hybrid frame, and we have to determine the degree of static indeterminacy. So first of all, we will count the number of members equal to, here if you calculate the number of members, 1, 2, 3, 4, here 5, 6, 7, this is 8, 9, 10, 11, 12, 13, this is 14, 15, 16, 17, and here you have 18, this one is left out, So this is 18, this is 19. So number of members are 19. Then we have to calculate the reactions. Number of reactions is equal to, here it is 3, 2, 3 reactions. So how many reactions do we have actually? The number of reactions, 12 plus 2, it is 14. So we have got 14 reactions. And how many number of joints? So you got to calculate the number of joints. So number of joints we will have here. This is joint number 1. This is 2. This is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and finally 14. The number of joints is 14. So up to this everything is clear. Then what we have to do is we have to calculate the C1 value. Okay, take joint M. At this joint M, C1 equal to 3 members are meeting. So 3 minus 2 equal to 1. Then take the member K. So member K, C2 equal to 4 members are meeting. So 4 minus so here it is 3 minus 1, which is equal to 2. 4 minus 1, which is equal to 3. Then you take the joint, pin joint I. So pin joint I we have here I, which is C3, that is equal to 4 members are meeting. So 4 minus 1 equal to 3. Then you take the pin joint F, C4 equal to here 3 members are meeting. So 3 minus 1 equal to 2. Take joint H. So joint H, if you take H joint is taken. So H joint 3 members are meeting. So C5 equal to 3 minus 1 equal to 2. Then take joint B. So joint B we have 3 members are meeting. So C6 equal to 3 minus 1, which is equal to 2. Then take joint D. So at joint D 3 members are meeting. So C7 equal to 3 minus 1, which is equal to 2. So we will add all these values up to C7. So what do we get is 3 plus 2 5 plus 2 7 plus 3 10 plus 2 12 plus 2 14 plus 2 16. So C equal to, up to C7 we have added, C equal to 16. Now we will substitute in this formula. So 3, this is static indeterminacy. D static indeterminacy. So 3 into 19 plus reactions 14 minus 3 into 14, then minus C is minus 16. So what do we have finally is at this location, summing up everything, we have finally the degree of static indeterminacy is 13. So this is how we solve the problems for a static indeterminacy of these type of hybrid frames. So what is a hybrid frame? You have both rigid joints as well as twin joints. So once you have these type of hybrid frames, you have to use this formula 3m plus or minus 3j minus summation of C. So here we have got C1, C2, C3, C4, C5, C6 and C7. So you add all these C values, that comes around 16. Substituting in this formula, finally you are getting static indeterminacy as 13. Thanks a lot for watching. I will get back to you with more number of problems on degree of static indeterminacy and kinetic indeterminacy. If you have any doubts, you mention in the comment section. Please subscribe the channel. Thank you.